Jonathan and I today are at Wolfspeed's lab, and we're going to take a look at how the traction inverter is assembled. And it's comprised of the bottom base enclosure and a top enclosure. So the bottom enclosure has the silicon carbide, and I'll let Jonathan describe how that interfaces to the overall mechanical structure. And then from there, I'll take on and discuss how the electronics works on the top enclosure.
Sure. So here we have kind of the power and mechanical chassis of the traction inverter system. And really these are components designed around our silicon carbide power module, which is the heart of the power section. So to start, we have the DC power coming in and this nice high performance, low inductance DC bus structure bolting onto the V+ and V- terminals of the power module. Underneath this busing structure is our DC link capacitors, so providing that local energy storage for the traction inverter system. And then on top, a discharge resistor with the high voltage points to make the DC bus measurement. And so coming to the silicon carbide power module, we have 3 bolted on our cold plate. The cold plate is the thermal management system that takes the heat that is generated from the losses of the modules and rejects it. So we have fluid in and fluid out to reject that heat. And then finally, AC busing coming out, the 3-phase terminals with our current limb current sensors sensing that phase current.
Good, so why don't we put the top on it? And so while Jonathan mentioned that we have the battery voltage, the current information, we put on the top, and here we can see the full electronics that interfaces to the silicon carbide to make the whole system work. So as Jonathan mentioned, we have the DC bus voltage. This is our 800 volts, which is then sensed by our isolated voltage sensing technology. And then we have the 3-phase currents that are available through the current sensors, and that information is then fed into our MCU as well. And then we will also have from our simulator or from a real engine, we'll have the motor position sensing as well as angular information. So with that voltage, the current, as well as the position sensing data, the MCU that we have is the heart of the system, where we are able to run FOC or field-oriented control algorithms to control the motor. And our gate drivers are essentially directly interfacing to the Wolfspeed silicon carbide modules. So there are basically the high side switches and the low side switches. And so each silicon carbide module has a high side and a low side. And we basically have a driver for each high side, low side times 3. And that's essentially 6 of the gate drivers. They are also powered by our isolated bias technology to power the gate drivers. And so you'll see the solution is quite compact. And essentially, the entire electronics is then interfacing via CAN bus to the central vehicular control system, if you will.